Welcome back to Math 103. This is video number 10 on voting. What have we done so far in our mathematical study of voting, and where has the math really worked for us? Well, we've considered 4 different voting methods, we've studied how they work, and we've seen that they are capable of declaring 4 different winners when applied to the same election. This may surprise us if we haven't thought previously about how different voting methods can be defined. It might surprise us that different voting methods are capable of disagreeing about who the winner is. And studying this makes us realize that the fundamental question of voting, which candidate best reflects the overall wishes of the voters, that's always the fundamental question, that is not so easy to answer. Even after we've accepted that election results can depend greatly on which voting method is used, there is still another level of surprise, of possible surprise, namely that fairness criteria are sometimes violated. We have certain insights about certain kinds of election outcomes which just seem unfair in general. We've taken 2 such insights and made them precise as fairness criteria. These are the majority criterion and the Condorcet criterion. We will go on to study 2 more fairness criteria shortly. Each of these 2 fairness criteria expresses an insight that if a certain kind of candidate exists in an election, then such a candidate is so worthy of winning the election that it would be unfair for anyone else to win instead. So these 2 fairness criteria are both about a certain kind of candidates who might or might not exist, but if that candidate does exist, that should be the winner. Now, we've also noted that as reasonable as the majority criterion seems, who could disagree with it? It seems so obvious, and yet we've seen that the board account method does sometimes violate it. We've seen examples. Furthermore, as reasonable as the Condorcet criterion seems, we've seen that there are 3 voting methods out of our 4 that sometimes violate it. We now move on to our last 2 fairness criteria, the so-called monotonicity and IIA criteria. We'll find out what that stands for shortly. This is a new type of fairness criterion. Each of these are a new type of fairness criterion. And in this new type of fairness criterion, there is a consideration of what should happen when an election is held and a winner is declared, but for some reason there is a re-vote. This can happen in real life. It could be, for example, that someone in the first election turns out to have been ineligible and we need to hold the election all over again. Or it could be that the first election was really just a poll, and we still have to wait for the actual election to take place. But we can think of these 2 events, the poll and the real election, as the election before and the re-vote. Or there are other scenarios as well. The 2 fairness criteria we now consider are based on this format. They are of this new type. They are based on this narrative that there is an election before and then there is a new election after. For each of these 2 fairness criteria, there are only very specific circumstances in which that criterion applies at all. Now here's a conceptual warm-up for the monotonicity criterion. I had monotonicity once. I was in the hospital for a week and a half. No, monotonicity is a technical mathematical term. So suppose that you are running for office. It makes intuitive sense that you should seek the highest level of support you can possibly achieve from each voter. In other words, you should tell each voter, give me all your support because the higher you rank me on your ballot, the better my chances of winning. That makes sense. It should be that way. But now imagine that the election uses a voting method whose inner computational workings are so strange, somehow they work in such a way that you're actually better off telling some of the voters, don't support me too strongly, don't rank me too high on your ballots, because I might lose if you do. That seems just utterly bizarre. There is a certain intuition that there is something very wrong with this strange hypothetical voting method, and that if you lost the election just because you received quote-unquote too much voter support and would have won if only you had received somewhat less voter support, then you could either say that that's an unfair election result, or you can say that the method itself is just irrational. To give another analogy, suppose that you're used to the idea, and you probably are, that the higher you turn up the flame underneath the soup, the hotter it gets. And yet, suppose that someone told you that no, at a certain point, as you turn up the flame, the soup starts getting colder. That would make no sense. So the intuition that these strange, counterintuitive things shouldn't happen is made precise by the monotonicity criterion. Now here's the precise statement of the monotonicity criterion. Suppose that an election is held using a specific voting method, a winner is declared. Now suppose that a revote is held. Election number 2 is held. For whatever reason, there is a revote. Now what happens in this revote? This is very important. What happens in the revote is that some voters change their votes to move the winner of the election, the original election, higher on their ballots. Moreover, no changes are made which move any other candidate higher on any ballots, and no changes are made that push the original winner lower on any ballots. In other words, the only changes are the ones that move the original winner of the election higher on some ballots. Now, you would think that that should only help the original winner. So the monotonicity criterion says, if all that happens, if these are the only changes that occur from election number 1 to election number 2, then the original winner should remain the winner in the revote. Again, this seems, as the other fairness criteria did, so intuitively clear that it's surprising, it's almost shocking that this criterion could ever be violated. But oh, it is. Let's look at an example. An election is held among political analysts, ranking Anne, Bob, and Claire as future presidential candidates with the following results. Okay, great. So we have a not too horrendous looking preference table here, and we can ask, who is the winner under instant runoff voting? Well, the candidate with fewest first choice votes is Bob, because Anne has 17, Claire has 17, Bob has only 16. Therefore, Bob is eliminated. Very well. Who's left? It's Anne versus Claire, and Claire has, by a substantial margin now, a majority of the first choice votes. So Claire has moved up a spot here, and so now Claire has 33 first choice votes. Anne has only 17, which means that Claire wins. Very well. So now we find out that in fact, this preference table that we just analyzed, in which we found that Claire is the winner, wasn't the real election. It was just a straw poll, right? It was a non-binding event. It was not the real election. When the real election is held, okay, which can be thought of as a second election or a revote, the preference table is not exactly the same as it was before. So take a look at the new preference table here, compare it to the old preference table, right? Compare election number 2 here to the original election number 1, and consider the following question. Precisely how does this preference table differ from that of the original election? And without determining the winner of the second election, is this a case in which the monotonicity criterion could apply? So please take a moment, pause the video, and think about these questions. Most of the votes are the same. These 14 voters have voted the same way in both elections. These 16 voters have not changed their votes. These 17 voters have not changed their ballots. But these 3 voters have changed their ballots. And notice, this here is election number 2, and the only change has been a swap in these 2 positions here. So in the first election, these 3 voters did not have C as high as they might have, did not have Claire as high as they might have on their ballots, and perhaps getting the idea that Claire was going to win anyway, they wanted to jump on the bandwagon and claim to have been supporting Claire all along. Whatever their motivation is, in the revote, These three voters have moved C higher. There are no ballot changes that move A or B any higher, and there are no ballot changes anywhere that move C lower. The only change has been to move Claire, the original winner, higher on some ballots. The answer is yes. This is a case in which the monotonicity criterion does apply. Okay. Before going on to the next video, find the winner of the revote under instant runoff voting. And then, what conclusion follows about the instant runoff voting method and the monotonicity criterion?